going a little further, an important thing about one-to-one is you can't do an inverse function for a function that isn't one-to-one. Because if you invert it, the inverse of the relation here is this. It's not a function. Because it has two y values for a given x in the domain, right? Of course, given x here, there's no y value, but here's an x value and here are two y values. Okay? It's not a function because a function gives you exactly one value. Okay? If we restrict the domain of this function, let's say that here's the vertex, so we restrict the domain. So here's our restricted domain, and now the function is one-to-one because we discard this part of it. Okay? And now, we have the inverse function on the restricted domain. Okay, and from here up is the domain of the range of the restricted inverse function. From here over is the domain of the restricted function, and they correspond to the opposite thing over here. The domain of this one is the range of this one, and the range of this one is the domain of this one. Okay, and it would be very good if you understood those things, because in applications often, for example, the flow problem, you get a quadratic model, which means your graph of that quadratic model is a parabola, right? But the model stops at the vertex because that's when all the water is out of the hole, okay? There's no more way for water to flow out, so that the part of the graph that goes up isn't relevant, so you have a restricted domain there. Okay? And the domain be from whenever you start to whenever the flow stops. And that function could be inverted. And you could use the inverse function then to find the time when the water depth is any number in the range of the original function. So, the point is that when you're trying to use functions in the real world, these domains and ranges often become relevant. Okay? Sometimes they're obvious, sometimes they aren't, but it's something you've always got to think about, which is why we talk about them in this course.